Hi, in this video I'm going to be talking about Newton's second law of motion. And the second law of motion defines acceleration. So acceleration is like, let's say you're moving at 1 meters per second and you have an acceleration of 1 meters per second, or that's also considered 1 meter per second squared. That means the next second you'll be moving 2 meters per second, and then the second after that you'll be moving 3 meters per second, and then so on and so forth. It's acceleration. It's speeding up or slowing down. And as far as acceleration goes, some people also say the word deceleration. Deceleration is just a negative acceleration. It's the same thing. People in science, we just say acceleration. We don't really say deceleration. So, yeah, the second law defines acceleration as force divided by mass. And in a previous video, I also said that the second law also defines what force is. It defines which force is equal to mass times acceleration, and it also defines what mass is. Mass is force divided by acceleration. It defines all of these. But this is really the main one. It's commonly written like this, but this is the law of motion, so we're going to talk about acceleration here. And a force, like I said, it's considered a push or a pull, or it's also mass times acceleration. So a force, the units for force, just like the units for acceleration is meters per second, the units for force is newtons. It's a newton. And the unit for mass is kilograms. You probably already know that. So let's say if you want to talk about a force, or let's say mass, I said force is a push or a pull, acceleration is speeding up or slowing down. Mass is the amount of stuff that something has contained within inside of it. That's one definition for it. It's also the measure of the amount of inertia an object has. So, for instance, let's say here's mass defined as force divided by acceleration. If something has 100 kilograms, if something is 100 kilograms, it would take 100 newtons to accelerate that object at 1 meters per second squared. And this is all coming out of this second law right here. And to be more exact with the second law, what it's saying here is that force and mass is directly proportional. So what directly proportional means is, if I was to multiply the mass, let's say if I want to have a constant acceleration, if I was to double the mass, it would take double the force to accelerate that object with a constant acceleration. And if I triple the mass, it would take triple the force, and so on and so forth. So they're directly proportional. And force over here is defined as mass times acceleration. So what this means is that mass and acceleration are inversely proportional. What that means is that this product right here of these two variables, mass and acceleration, is equal to this constant. So this force, if you have a constant force, then whenever you accelerate an object, how can I put it? With the constant force, if you was to double the mass, the acceleration would halve. And this would just cancel out to equal this constant. And if I triple the mass, the acceleration would be 1/3 of the original with the constant force. And what this right here, this relationship says is that force and acceleration are proportional. So what that pretty much means is a constant force causes a constant acceleration. So with a constant mass, if I was to double the force, the acceleration would double. And if I was to triple the force, the acceleration would triple. And this is probably one of the biggest or most widely known parts or ideas of the second law of motion, to where it's constant force causes a constant acceleration. That's probably one of the most widely known ideas of this law right here. And forces and acceleration and mass is used all over physics. In kinematics, Uh, it doesn't really necessarily use force so much, but it does use acceleration. It doesn't really use mass that much either. But in momentum, just a whole bunch of concepts in physics that uses these ideas, these relationships right here. And I'm going to be diving into those in the future. So until next time, this is all I have to share for the second law of motion, and see you later.